Hey everyone, in this video I'll show you how to use Kotlin Coroutines. We'll cover suspend functions, we'll define what the launch and the async builders are, and how to use them in your async code. I'll walk through some examples and explain things step by step, so even if you're new to coroutines, you'll be able to follow along. So let's take a look. Here I have created a new project. A new empty project. Let's take a look at some definitions of what coroutines are, what suspend functions are, and what the run blocking code is. So a coroutine is a lightweight concurrency primitive, not a thread, but runs on one. So these are basically containers that run asynchronous code inside. It's fast and scalable. We can launch thousands of them. Compared to threads, threads are expensive and they're not easy to, they're slow to create, basically. Enables asynchronous code written sequentially, so we're going to see how this is done. And there are two main builders, launch and async. Context switcher is with context, and scope basically defines the lifecycle of the coroutine. It propagates its context and cancellations to its children as well. A suspend function marks a function that can pause and resume without blocking the thread, and we'll see an example of that as well. And a suspend function must be called from a coroutine or another suspend function. They cannot be called outside of those. The run blocking basically blocks the current thread until the coroutine completes. So basically the code inside of the run blocking can be asynchronous. And it's the bridge between synchronous and asynchronous code. For example, from main and tests. Now to start, I'm going to create or write run blocking here for the entire main function. And now all of the code that we're going to write here can be asynchronous. So I'm going to start with, writing a function. So I will do launch example. And I need to create this function. So function launch example. Okay. In here, I want to do some delay. I will delay it by 5 seconds. And I want to put some print statements. Print line. Launch 1. End it. Okay. Now because delay is another suspending function, and we can see this by the squiggly line here, the parent function, which is launch example, also needs to be suspending. So let's make it a suspend function. Now we see that launch example is also a suspending function. What this means is basically the thread is not blocked when we execute this launch example. Okay, so if I run this, I should see launch ended. And that's what we see. Now, let's say I wanted to do another delay. So let's say delay of 3 seconds. And let's do print launch 2. Okay, So what this is going to do is going to delay. Let's say it's doing some arbitrary work, then it's going to print that the first delay or the first print statement is complete. Then it's going to delay again, and then we're gonna print the second print statement. That's should be pretty straightforward because it's all sequential here. Okay, and that's what we see. We see launch 1 ended, and then launch 2 ended. Now I can put a print statement here. So print line end of main. When this code is being executed here, it will come after all of these print lines here. And this is what we should see. Launch 1 ended, launch 2 ended, and then end of main. So this is straightforward, nothing special here. Now what happens if we start adding these builders? Launch, async. Let's start with launch. Let's wrap this first delay in a launch builder. Okay. Now in order for us to launch a launch builder or to create a launch builder we need to have a coroutine scope for the entire function here. So let's create another one. Coroutine scope. There you go. So what this is going to do is this scope here is going to inherit the context and the cancellations of its parent. In this case, this will be run blocking. So if we cancel run blocking, or if it throws an exception and it breaks, all of its children will be cancelled as well. Now, what do you think will happen here now that we have this launch? Now, this builder launch is a fire and forget builder. So it means that we're going to fire this coroutine. We're going to do the work here and we'll forget about it, meaning that the compiler will launch it and then it will continue directly to the next line. So this is exactly what we're seeing. We see launch 2 ended, which means that the launch here, the compiler started the launch and then right away went to delay of 3 seconds and then it launched. It printed the launch 2. And after the 5 seconds are complete, the launch coroutine that we have here ended with launch 1, and then the main function ended as well. How can we make this sequential? For example, let's say I want to launch this, but then I want to wait for the execution to finish of this launch before I move to the next delay. In order to do that, we can assign a variable to this launch, and the variable is usually a job, because this is what the launch builder returns. They return a job. Now, if we want to wait for this job, the way to do it is we're gonna type job.join. And what this is going to do is it's going to wait for this coroutine to complete at this point and then move on to the next execution. After we run this, we see launch 1 ended, and then launch 2 ended after 3 seconds delay, which is how we started initially without the launch that we wrote afterwards. Cool. What if I want to launch 2 separate jobs? And we can do that. We can write another launch, and we can put the second instructions inside of it. In this case, I want job, let's call this job 1, and let's call this job 2. Job 2. In this case, and let's put a print line statement here, print line launch example ended. What do you think will happen here? Let's take a look. So what we're seeing here is very expected. We have the first launching, doing some arbitrary work for 5 seconds, and then finishing. Then the second one, however, the first one and the second one are launched one after the other, basically. They're or pretty much almost at the same time. So when the compiler hits this line, it launches this coroutine, and then it moves to the next line right here, and then it launches the second one, and then it moves to the last line, which is finishing the example. This is what we're seeing here. And then these 2 coroutines are working. And after they finish, the first one to finish should be job 2. This is exactly what we see here, because it took the less amount of time. And then job 1 is the last one to finish because it took the longest. Exactly what we see here. Now, where are these launch jobs being executed? Well, if we look at the documentation, they are actually on a default coroutine. So there are actually 3 types of coroutines. There is default, which is basically used for computation, hard computations or long computations. There is also, sorry, I'm looking at the wrong documentation. Okay. Please ignore this. Okay. So what if we want to wait for both jobs to finish before we print the last print statement? And there is a function to do that. We can do join all, and then we can say job 1 and job 2. So we wait for job 1 and job 2 to finish before we print the last statement. Okay, let's see. And this is what we see here. So job 2 finished earlier than job 1. And then at the very end, we see the last print line statement. This is because of this join all. One more thing to see here is we can cancel a job. So we can do delay. Let's delay by 2 seconds. And let's cancel job 1. Job 1 dot cancel. Okay. So what this will do, this cancel here, is going to say, okay, so the compiler launches the 2 coroutines. Then the compiler delays by 2 seconds, and then it cancels job 1. Job 2 is still executing within these 2 seconds, and job 1 is also still executing within these 2 seconds, but it will be cancelled. So once we do this, what this should do is eventually, actually, let's take a look. Okay, so what this does is it launches job 1, it launches job 2, waits 2 seconds, cancels job 1. And then we see, because it cancels job 1, it will be this line. This is executing in a separate coroutine, so the compiler continues here, prints the last statement, which is exactly what we see here. Then job 2 finished, and job 1 never printed because it was cancelled. Okay. And I think this is pretty much all for launch here. Actually, there's one more thing. Let's print where these jobs are running. So thread dot current thread dot name. Okay. Let me copy this on the second line here. And let's take a look. Okay, right now we see that they run on the main thread. And what we can do here is we can put a context. So we can do dispatchers dot, and there are three main dispatchers basically: main, default, and IO. Main is basically running on the main thread. Default is used for hard computations, long computations, CPU intensive computations. And IO is used for networking or accessing the database. It's not that you cannot use any other one, any one of the three for accessing the database, for example, but IO is optimized for that. So either a network call or accessing the database. Okay, so if we do this and then we print the thread here, we're gonna see this. So launch 2 ended on the main thread. It was executed on the main thread, but launch 1 was executed on this default dispatcher, worker 1. The last thing I want to show here is try catch. So let's say launch 2 throws an exception. Throw exception, and then let's put launch 2 failed for whatever reason. Now in order to capture this in a try catch, we need to put the try catch around the suspending function, not within the coroutine scope, because that's not going to work. So we're going to capture the exception and then we're going to print it. And let's take a look. Okay, so what happened? We started the two launches, the two builders. Launch example was printed because, again, the compiler skips these and then prints the last one. It skips them because it launches them and it returns right away. Launch 2 ended, which means that after 3 seconds delayed, job 2 completed, but for some reason it failed through an exception. And now this exception is propagated to the coroutine scope, and the coroutine scope propagates it backwards to the run blocking scope. And now the run blocking has a try catch, and this is where the exception is being called. And what happened to job 1? Job 1 never finished because job 2 threw an exception. And this is actually how the coroutine scope works by default. it cancels all other children whenever one child of its children fails. Okay, and I think this is all for this section. So let's take a look at async builder. I cleaned up the code again, and we're going to start with, in this case, this won't be called launch example, but it will be called async. Okay. So we saw that the launch coroutine builder launches the coroutine's block, and then it returns, meaning that it returns a job, which we can use to like a handle to cancel or join on the job or do any other thing that we can with the job. However, it does not return a result. So let's say you want to execute a coroutine, but you want to get a result back. And in order to do that, it is with the async builder. So let's actually write this. Okay, so let's create a val result equals async builder coroutine builder, and here let's just do work. Let's create a function that does some work that we're going to implement right now. Okay, function do work. Okay, let's say that we delay for 4 seconds here. Okay, delay is a suspending function which can only be called from other suspending functions or coroutine scope. We don't have a coroutine scope here, we don't have a suspending function yet, but we can make do work be a suspending function. All right, so what this is going to do here is we're going to call an asynchronous builder here. It's going to create a sequence of block instructions to do some work, and then eventually it will return a result. And in order to return such a result is we can do deferred. Let's say it returns an int. So the type of this result will be a deferred object, which will be returning a result of int. And in order to wait for this async to finish for us to get the result, we need to call on the async block, we need to call dot await. And we also need to put the return. And now our do work needs to return an int. So after some delay, we'll return an int. Let's say, sorry about that, I see what happened here. So the result now of this async function will be an integer, because this is a deferred, and on this deferred we're going to wait, and then eventually we'll get the result. Another way to write this would have been like this. So we're going to put this as deferred int, and then once we execute the async call, we want to print it. So print line, let's print the result, and the result will be dot await. Okay, let's take a look what this prints. And it's exactly what we see. 0. This is because the work here is being done. We're going to wait for the result, basically, for this deferred object to be completed. Once it is, then we're going to fulfill this print line statement, and then we'll move to the last one, which is end. And then the very last is the end of main. Okay. So this is the second builder for Kotlin Coroutines. And I think this concludes this tutorial. Thank you for listening.